Hello everyone, hope you are doing good. Welcome back to my channel. Today we are at day 3 for the March daily lead code challenge, and we have a medium question. For the last 2 days we were seeing some easy questions, but finally we have a medium question. This is a very good question, I will say. Like, see, the level is easier. Like, this is marked as medium, but it's slightly on the easier side. And obviously the best part here is there are so many ways to do this question. Okay, so I will be showing you multiple ways today. I mean to say, I will show you three, like, most I will say, like, distinguished ways, because see, there are multiple ways possible, but again, like, one of the way you are doing it in one of these three categories, they will be lying. Okay, so on a overall there are three ways in which you can do. I will be showing all the three ways. Okay, let me quickly begin. So I am assuming that you have gone through the question, because it's a very easy question, so I will not take much of your time in reading the whole thing. Okay, so let us quickly dive into it. Let me zoom in. Let us begin. It is 2161 partition array according to given pivot. Okay, so if you see the input, basically what you are given a nums array. Okay, and you're given the pivot. Okay, first of all, let us see the features of this. First of all, the nums length. Okay, that is the input of your length of your input is going to be around 10 power 5. Okay, now each element in this is going to be, see, both positive and negative elements are possible, and finally pivot is equal to element in nums. Okay, so we know that there are positive and negative elements, and obviously since it's a medium question, so it is going to be 10 power 5 in range. Okay, so the length of the input. So this is our nums array. Okay, 10 power 5 could be the range of this, and we are given a pivot. Pivot is always going to be element in this. Okay, so what you have to do, it's very simple question, nothing you have to do much. See, whichever elements in this are less than pivot, for example, in this case 9, 5 and 3 are less than pivot. Okay, pivot is 10, by the way, and anything which is less than 10, you'll have to take them and keep them in the starting of the array. Okay? So this is the answer that you have written. In the answer, any element which is less than pivot should be mentioned first, and remember, the best part here is they are asking you to keep them in the same sequence in which they appear in the nums. So what that means is, see, 9, 5 and 3 are three elements which are less than pivot. Okay, now see the sequence. First 9 appears, then 5 appears, and then 3 appears. So they should be arranged in the same exact same sequence. Okay, so we are trying to maintain their sequence. What is sequence? Sequence basically means in which order they are appearing. Okay, first, see, among the elements which are less than pivot, we have to preserve the order. So I will again repeat, among the elements which are less than pivot, we need to preserve the order. So first 9 will come, since it is, see, 9, 5 and 3, let's see where they are present. First 9 comes, then 5 comes, and then 3 comes. So exactly same order, we'll have to write them in the answer also, right, in the final output, right? Next, after capturing all the elements which are less than pivot, then you need to go for the elements which are equal to pivot. In that case, obviously, since they're equal, obviously there is like within this range, there is no sequence like that. Okay, I mean to say that after, see, we preserve order for elements which are less than pivot. Now we need to preserve the order for elements which are equal to pivot. I know this doesn't make much sense, because since they're equal to pivot, so that doesn't make sense how we are going to preserve the pivot. That's up to you, but yeah, it doesn't make sense according to me. So you can just write the elements which are equal to pivot, as simple as that. Okay, now after that comes the place where we need to preserve the sequence for the elements which are greater than pivot. Okay, in this case, if you see 12 and 14 are two elements, first 12 comes and then 14 comes. So we need to preserve the sequence, and we have to write them after capturing the element which are less than or equal to. Then we should write the elements which are greater than the pivot, and while writing them, we have to ensure we are preserving their sequence. Okay, preserving their order in which they appeared. Okay, so this is the final output. So please go through it. Question is very simple. I'm not repeating much. Okay, because it's simple, I will always give the question like in the description. Take it and go through it, but yeah, that is all we have to do. Okay, so the only thing that is different here, okay, see, the arranging like this anyone can do, right? The only thing which is different in this question that I am seeing is they are asking you to preserve the sequence. Okay, the way in which the things are appearing, so you need to preserve the sequence in three ways. First thing is, anything element which is less than pivot, among them you need to preserve the sequence. That is point number one. After that, any element which is greater than pivot, we need to preserve the sequence for them also. Then obviously this part doesn't make sense to me, why I need to preserve the pivot here, but again, the elements which are equal to the pivot, for them also need to preserve the sequence. It doesn't make sense, so you can simply write, let us say there are two elements which are equal to pivot, so you can write both of them as it is. Okay, so obviously that doesn't make sense, which how we can preserve pivot in this, right? Yep, so these are the ones, and yeah, you can go through the other examples also. And yeah, it's a pretty simple question, so I'm not taking much of your time. Let us quickly dive into the solutions. First solution that I'm going to show you will take, first of all, we'll have to go through each element. So obviously all solutions that we are going to see now is going to often in terms of time complexity. Okay, that is a fine thing. Okay, that is obviously that is going to happen. Okay, without that we cannot go, since we need at least so we have to visit each element, so it is going to often in terms of time. But this is something that we are going to focus on. Okay, so the first solution that I'm showing you, the space complexity is going to often. Okay, let's see what we're doing. So I am creating three areas basically. In one area I will be storing all the elements which are less than a pivot. Second area I will be showing all the elements which are equal to pivot. See, L means less than pivot, E means equal to pivot, and G means greater than pivot. Okay, so let's see how we are doing it. We are going through each elements. If the number is less than pivot, add it to the L. If the number is equal to pivot, add it to the array marked with name E, and if it is greater than pivot, add it to the list marked with the name G. Okay, now since you are obviously adding the way in which they are occurring, okay, so obviously in this part, if you see in this part, let us say all the elements are going to appear in the list L. Obviously the sequence will be preserved, because we are going from left to right. Okay, all the elements are being taken from index 0 till index n minus 1 in the same order. Okay, so for that reason, the within each of these, obviously the we are preserving the way in they occurred. Okay, we are preserving the sequence. Okay, as simple as that, right? Fine. And finally we have written, like, we are simply concatenating both all the list, and finally we're getting the answer. If you see L plus E plus G, so yeah, we are routing it. Now if you talk about the time space complexity, see what will happen is, I agree. See, I agree. See, normally what we do know, when we have to return output, the space that is taken by the output should not be considered for your space complexity. I agree with that. I completely agree with that. But in this case, if you see what we are doing, see, ultimately you are storing your elements in this. Okay, so let us say we can ignore one array, because this will be returned finally in the output. Or we can do is, you can use the extend function L dot extend E, then L dot extend G, like that you can do. So one array, yeah, you can say that, okay, this is required for the output, that's why we're creating it. But for the other two arrays, definitely you are using some space, right? Which is not the requirement of the output, but you are using it for your own calculations. Okay, so definitely these will take, this will come in the calculating. This will be, taking some significance. It will be taking some worthy space. For that reason, it will be part of the space complexity, right? Because of that reason, it is going to often in the worst case. Okay, as simple as that, right? Now let us quickly dive into the next solution. See, because it's an easy question, I'm not going too deep, because obviously the code is self-explanatory. When I give them in the comment section, I expect you to go through them, and if you have questions, you can always reach out to me. They're very simple. That's why I'm not taking much time here. Okay. Now the second is going to be slightly bigger code. See, first code that I'm showing you and the third code that I'll show you are going to be very, very small. Okay, but yeah, the currently that I'm going to show, the second code, it's going to slightly longer, but don't worry, it's again simpler. Okay, what we're doing, the idea here is, instead of creating the list, see, here we're creating the list. Instead of doing that, what we will try to do is, we will be trying to avoid using the list. Okay, that is the reason why it will be often space complexity. But because of the way it is implemented, we are going to go through the input, that is the nums array, two times. Okay, it is kind of a two-pass solution. So let us quickly see what we are doing. First of all, we are capturing the length, and then we are declaring two variables. So see, in this, just count the number of variables. Okay, because then when you see the third solution, you will see how the optimization is working. Okay, so yeah, just count how many variables we are using. So this is the first variable that we are using, L equal to 0. This means that it will count the number of elements which are smaller than the pivot. Okay, similarly this will count the elements which are greater than pivot. Okay, let's see what we're doing. First of all, this whole for loop is just for counting. Okay, so if I is less than pivot, we are incrementing the L. Okay, which signifies the element which are less than pivot. Similarly, if it is equal to, sorry, yeah, it is equal. Okay, so I have written greater here, but it should not be greater, it should be equal. Yep, it should be equal to pivot. Okay, so if the element is equal to pivot, just update this. Okay, fine. Ultimately, we are creating an answer array. Okay, then we are declaring again three more variables. What are they? See, this will tell us where the next element, which is less than pivot, should go. Similarly, this will tell us where the next element, which is equal to pivot, should go, and similarly, this will tell us where the element which is greater than pivot should go. Okay, as simple as that. So let's see what we are doing. Again, we are going through the array. If this time I is less than pivot, what we have to do, we'll have to send that element to this particular index in the answer. Okay, remember this particular index, how we are getting that. See, it is starting from 0. Okay, simple as that. So this is again pretty clear, right? Any element, obviously the smaller elements will start from 0. That is this is pretty clear. Okay, after doing that, we are just incrementing it. Okay, let's see the other case. If it is equal, then where you have to start, obviously it is going to start from this. Okay, see, for example, let us say there are see how it is being said, it is starting from L. Okay, let us say there are three elements which are less than pivot. Okay, so from index number 3 onwards, it will start, we will start showing the elements which are equal to pivot. Okay, see, in this case there are three elements which are less than pivot. Okay, so if you see the first place in which the index 10 came, it is index number 3. Okay, that is why we are doing E dot, see, the index in which the will start showing the elements which are equal to pivot will be L. Okay, what is L? L is basically the length of the elements which are less than the pivot. Okay, so from there we'll start showing it. Okay, yep, that's what we are doing. If it is equal, what we are doing, we are going to store it in E underscore IND. Okay, we are going to store that element, and then we are going to update this, right? Now this, the elements which are greater than the pivot will be stored in this index. Okay, L plus E. Okay, if you see in this case, if you see a total, there are five elements which are less than or equal to pivot. So in this case, if you see the first index in which we store the element which is greater than pivot is index number 5. Okay, same thing we are doing here. Okay, G underscore I and D will be the first index in which we will be storing element which is greater than pivot. So if you see, that's what we are doing. And yeah, we are incrementing this again whenever we are doing this, right? And finally we're returning the answer. This is clearing all the test cases. You can go through it. Okay, but I'm just telling you the highlight of the solution. This solution is means that we are going through the array two times. This is the first time we are going through, and this is the second time we are going through it. Okay, two times we are going it. And obviously see, we are creating the answer, but this is the requirement of the question. Okay, this is not something that we need to go through in our algorithm. We don't need this. So that is the reason why I will say this is O of one space complexity, because in our calculation, see, this is the requirement of the question, that's why we're creating it. But in our calculation, we are not using any extra space. But yeah, we are using so many variables that I agree with that. But again, they are constant for every, irrespective of the length of the nums, these many variables will be used. Okay, so they are irrespective of n. Okay, that's why it will not be coming in the space complexity. It is O of one space complexity, but it is a two-pass solution because we are going through the array two times. Again, though it is often, still it is a slightly costly one because we are going through the array two times. Remember that part. It is definitely costly because remember, the array length can be 10 power 5. Remember that. Going through the array that is 10 power 5 elements two times will be not a, like, it will definitely be not a light operation, it will be a heavy operation. Okay, so we'll try to avoid that in the next solution. Now comes the final and the most efficient solution. See this case. Now count the variables here. See how many variables we used here. Three variables, sorry, two variables here and three variables here. Okay, so total five variables. I am not, including the length and all. Okay, because that is obviously needed. Okay, now in this case, you see how many variables we're using. Just two variables we are using, and we are getting the solution. See what we are doing here. In this case, while creating the answer, what we are trying to do is every element will be equal to pivot. Okay, when this array is created, obviously the length of the answer is going to be n, and every element in this case will be equal to pivot from the starting itself. Okay, now see what we are doing. The idea here is, for elements which are less than, pivot, we will start capturing them from left to right. Okay, similarly, the elements which are greater than pivot will start capturing them from right to left. Okay, I hope you are getting my point. See what will happen. See, all the elements which are less than pivot, we will start capturing them from left to right. Okay, that is first. If you see what will happen, 9 will come, then 5 will come, and then 3 will come, right? But then all the elements which are greater than 5 will start coming from the right. That is, we will go through this. Okay, this way, like from right towards left, we will go. Okay, first 14 will come and then 12 will come. Okay, something like that. So this 10 will not be, even going through it, because if you see, all the elements are pivot by default. Okay, so we are not going to be, assigning this because they're already there, right? See how it works. What we're doing is, I is going to be from 0 to n minus 1. See, this is a single loop. Okay, we are going through elements only one time. See how this works. If nums of I is less than pivot, what you have to do in L, okay, in the index L, what you have to do in the index L, assign nums of I, okay, then do L plus 1. Okay, so remember, this is if condition. Again, this is if condition. Remember, this is not else condition. This is a if, this is again if. Okay, this is not else if. Remember that part. So this will also be executed and this will also be executed. See this, what is happening now. What we are doing is, we are trying to capture the element from the last. Okay, we are doing n minus 1 minus I. That means, if you see, the zeroth element is taken, and at the same time the last element is taken. Similarly, the second element is taken, and at the same time the second last element is taken. The third element is taken, and the same time the third last element is taken. Okay, the same thing we do, but this time we'll try to find the element which is greater than pivot. Okay, because we have to maintain the sequence. So what we are doing, if nums of n minus 1 minus I is greater than pivot, what we have to do, in the index G of the answer, store this variable and do G minus equal to 1. That is, G is equal to G minus 1. Okay, we are doing that, right? So this will ensure that all the elements which are less than pivot are captured in the same sequence, and similarly, all the elements which are greater than pivot are captured in the proper sequence. Okay, and obviously the elements which are equal to pivot are already there, because we are initializing all the elements which pivot only. Okay, and finally we return the answer. So if you see, what are the advantages, this is single pass and it is using only two variables. If you see the other solutions, it was using around five variables, two here and there are three here. Okay, so total five variables it was using. I agree, like, maybe you can avoid one of them. Still, we were using four variables. In this case, we are using just two variables. And even, see, this is not even the point. The point is, we are going through the array only once. Okay, remember, we are going through the array only once, right? Again, some of you may ask me that, yeah, the way you're using it, because I is going from 0 to n minus 1, but see, you here also you're referring the I, and let us say zeroth element, here also you're referring the zeroth element, and again through this also you'll be referring the zeroth element in some time, in some point of time. But try to understand this fact, my friends. See, referring element is not a costly operation, okay, because it's array. So in O of one time, you can refer any element, okay. These are indexed, right? So you can refer zero, or any index, okay. Let us say L plus one, L minus one, any index like that. You can refer in O of one time. So referring element is not taking time. Remember that, it's O of one. But going through all the elements is taking the time, okay. So this part is going to take time. But see, referring element, like I'm referring the ith element, I'm referring the zeroth element. Those things will not take time, okay. It is O of one. Remember that. But yeah, going through array will take time. So don't like say this kind of view that, see, nums of 0 will be coming here also, and then there will be a point where nums of 0 will be coming here also. Okay, when we are in the last element, then this, this part will be zeroth element. Okay, so yeah, I agree with that, but still remember, referring element will not take too much time. Okay, it is of one, it is of constant time. Okay, but yeah, going through the elements will take time. So in this case, if you see, there were two loops happening. Okay, there was two loops. Okay, this is the first loop and this is the second loop. But in this case, if you see, there is only one loop, and yeah, within the single loop we are referring every element two times. I agree with that. In a single loop we are referring every element two times. I agree with that, but still, it is a single loop only, right? That's why it's a O of n solution. Okay, as simple as that. Again, it is O of one, that is, we are taking constant space because I'm not including this in my space complexity, because this is a requirement of the question. That's why we're creating it. This is not something that we need, to get the solution. Okay, what I mean to say is, in our algorithm, okay, that is still I get the answer, I need not use this. Okay, as simple as that. That means to get the answer I'm not requiring it, but yeah, just to store the variables and return it, I need it. Okay, so you can go through like multiple solutions, LeetCode solutions. They will argue the same point, that if you need something as a result, okay, as a intermediate results, then obviously it is a part of your space complexity. But if you are something, see, because they require the answer in this format, that's why you are creating it. Otherwise this need not be created, so this will not be part of the space complexity. Okay, as simple as that. Yep. And obviously it's O of n solution and O of one space. So I've shown you three solutions. The first solution, it is O of n both space and time. Okay, we are creating three arrays in this. Okay, and we are going through the element only once. Okay, single loop. In the second, it is O of constant space but O of n time. In this case, we are going through the elements two times, first loop, second loop. Okay, and there were total five variables. Okay, total five variables. In the third solution, we were only using one loop, and we are using only two variables, and it is O of one space and O of n time. So this was the most efficient solution according to me, in terms of space and time complexity, and also in terms of the number of loops that we have. Okay, and number of variables that we have. So yeah, and that was all for this particular video. I showed you three ways. I am assuming that yeah, the other ways also that you could think of will be somewhere or somewhat related to any one of these three. Okay. Yep. So yeah, and that was all for this particular video. I hope you enjoyed the video. And see, this question was on the easier side. That is the reason why it had multiple ways to do it. But again, it's up to you how you are doing it. But remember, whenever such a question comes in an interview, see, since it's easy to solve, that's why the interviewer will definitely, I will take it in return from me. The interviewer will definitely ask you 3 to 4 ways of solving it, because since it's the easier one, they see anyone can solve it. Okay, so definitely if it is a 30-minute interview, or let us say 20 to 25 minutes interview, you should be able to code at least 3 to 4 solutions in those 20 to 25 minutes. Okay, only then you will be considered for the next round. That is how the things will be. Okay, because it's on either side, that's why just solving it will not be enough. You have to solve it in multiple ways. And remember, in every way there you have to show like, yeah, this is how the difference is coming. That is, you have to start from a very brute force type way, and you have to keep optimizing it. Okay, no two solutions should be the same. Okay, you should not be doing the same thing like in a different way. You should be doing the total different thing. Okay, as in my solution, see, we have reduced the loop here. In previous one there were so many loops. Okay, similarly the number of variables we have reduced. Similarly here we are taking three loop, three like list. Here we are taking only one list. See, those things will matter there. Okay, so yep, that is how I have done it. Yep. So that was all for this video, friends. If you like the effort, if you feel this effort could be useful for someone who cannot afford paid courses, so please subscribe to the channel. This will ensure that it reaches multiple people who may not be having resources to buy a paid course. So this is my 132nd day. From last 1 3 2 days I am continuously making the videos and uploading them. And obviously I see, my aim is I should be uploading a quality content, so that people who cannot afford paid courses can get some benefit out of it. So if you like my approach, if you like my initiative, if you like the quality of this video, please subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow, and thanks a lot.